All right, in this section we're going to talk about how to solve other types of equations. There's going to be a couple different ones that we're going to look at, but we're going to solve other types of equations. So that's what section 6 is about in your college algebra book. The first type of equation that we're going to look at is it's going to have x squared, or x to the fifth, equals 9x to the third. Now when you look at that, first of all, we've been talking about quadratic so far or linear stuff, and none of those have had higher exponents other than 2. So for this particular thing, we're going to deal with it like a quadratic kind of, or we're going to use factoring. But in order to do that, we got to have everything to one side versus the other. So I am going to subtract 9x cubed to both sides. So I end up with x to the fifth minus 9x to the third. Now, if they were the same size exponent, I could add and subtract them together, but since they were not, I have to write them as two separate pieces. Now, from here, I'm going to ask you, what can I take out of both terms in this equation? I can take out x to the third is what they share in common. Now, when I take out an x to the third, I end up with x squared left over and a minus 9. The reason why it's x squared is because if you have 5 of them and you take away 3, you have 2 left over. If you had 3 of them, take all 3 of them away, you have no x's left over. Now from here, very similar to what we did in section 4, we're going to set each group equal to 0 and try to solve it. So x to the third equals 0, x squared minus 9 equals 0, and now I try to solve for x. In order to get rid of cube, you're going to do what we call cube rooting it, which means I'm going to put a 3 right in that space right there. The cube root of x cubed is x, and the cube root of 0 is 0. If I add 9 to both sides, in order to get rid of something squared, I square root it. And when you square root something, be very careful. It should be plus or minus 3. And the reason why it was plus or minus is because if I take negative 3 and square it, I get 9, and positive 3 and square it, I get 9. So very careful with that. Now again, I ended up finding actually 5 different answers. I found this one 3 times, and I found this each once. 3 plus 2 is 5, and that was the highest exponent. So I have 5 answers for there. So what I used again was the zero product property in order to solve that. But I used factoring, and that's if we're set up that way, first of all, that's how I'm going to solve those problems. The second type of factoring that's going to show up is a technique called grouping. Now for this one, I've already set it equal to 0, so everything's okay that way. But grouping means I'm going to look at just the first 2 and the last 2. This especially is used when you have 4 terms. When you have 4 terms like that, you can group them, first 2 and last 2. From the first 2, they share an x squared in common. That leaves them with x plus 3. And in the back 2, it shares in common a negative 4. Now when you factor by grouping, what needs to happen, or what you hope to have happen, this x plus 3 and x plus 3 should be identical. If they're not identical, factor by grouping does not work. Alright, and then we have to pursue other avenues in order to get that answer. But what you need to look at is you want to make it so that those 2 things are the same. And they are. So now this whole term and this whole term, what they share in common is an x plus 3. And then in another set of parentheses, if I cancel out the x plus 3's, I have x squared minus 4. And now from here, again, I'm going to set each group equal to 0. And I'm going to solve for x. So subtract 3. Add 4 to both sides. And then square root it. And the square root of 4 is plus or minus 2. There again, I got 2 answers for the plus or minus 2, and negative 3 is 1 answer. That makes 3 answers total, which was the highest exponent. If you want to always check these, you can put them back in the original equation and see which ones work. If they don't work, then you have to throw them away. So, which leads me to my next one. And again, I use that factor by grouping method when I have 4 terms. Okay, so keep that in mind. On the next particular thing, when you have fractions involved, this is where it gets a little dicey. And the reason why I say that is because most people, especially those of you who are taking college algebra for the first time, or you haven't had a college algebra class in a while, or an algebra class for that matter, fractions can be daunting for a lot of people. As soon as they see them, they cringe and they think, I can't do this. But you can do it, and it's okay. Now, what I'm going to do is, because with this, I'm going to multiply everything by a common denominator in order to get rid of all fractions, and therefore I don't have any more. So the first thing I do is I look at each of the pieces, and I try to see if any of them can factor. X is just x minus 3 can't factor, but x squared minus 9 can factor in an x plus 3 and x minus 3. Those can factor. So I factored them all out. And now what I'm going to do is I'm going to try to come up with a common denominator between all three terms. So what I do is I start with the first one, which is x, and then I jump over to the next one. X minus 3 is different from just x. And then over here I have x plus 3 and x minus 3. Well, the only one that's different is x plus 3. If they're different, write them on the outside. If they're not different, you don't have to write them on the outside, unless there's more than one of them. Now what happens is I end up multiplying this into each of the pieces. It's going to go into the front, it's going to go into the middle, and it's going to go into the back. On this first one, I have x times x minus 3 times x plus 3 times 3 over x. Now for this, the x's cancel, and I'm left with x minus 3 times x plus 3 times 3. When I FOIL that first one out, I get x squared minus 9. And then I multiply it all by 3, and I end up with 3x squared minus 27. So what I did there is I multiplied it into the first terms, and the x's canceled out, and whatever was left over, I just multiplied all together. When I go into the next one, x times x minus 3 times x plus 3 times negative 2 over x minus 3. Now what cancels? The x minus 3's cancel, and I'm left with multiplying the rest of that out. I'm going to multiply this one with this one first, so I have negative 2x times x plus 3, which is negative 2x squared minus 6x, equals, now I have x times x minus 3 times x plus 3 times negative 12 over x plus 3 x minus 3. This cancels with this, that cancels with that, and I'm left with, I kind of left myself in no room here, negative 12x. If I combine like terms over here, I have x squared minus 6x minus 27 equals negative 12x. Now I have a quadratic that I can solve. So I add 12x to both sides. So I have x squared plus 6x minus 27 equals 0. So my goal was I'm going to eliminate the fractions so that I can get it to something that I can solve in a quadratic format. Okay, so for this, I'm pretty sure it can factor into x plus 9 and x minus 3. And when I set each group equal to 0, I get x equals negative 9, and I get x equals positive 3. Now, there's a problem with that. One of those answers is what they consider extraneous because of the fact that if I put one of them in there, it will give me 0 on the bottom of one of the denominators. If a number gives you 0 on the bottom of a denominator, you need to throw it away. If both answers get thrown away, then you have no solution. So you go through all that work to find out that nothing works. It's kind of frustrating, I know, but that's what you'd have to do for that particular case. If I put negative 9 in there, negative 9 in here is okay, negative 9 minus 3 would be okay, and negative 9 here would be okay. But as soon as I put 3 in there, 3 in the first one's alright, but 3 in the second one's not. I gotta throw it away. If it makes 0 for one of them, you need to throw it away. Okay, so the only answer I'd have for that one is negative 9. So make sure you check them. If it has fractions involved or square root involved, you need to check your answers for sure to make sure that they actually work. You could get an answer and think it's great, but realistically it could make the bottom equal to 0, or it could make the square root equal a negative number, and that's not possible. So you need to be very, very careful in making sure that you actually check your answer. Now, as far as the square root one looks like, 5 equals the square root of 4x minus 3. When you have a square root involved, what you'd have to do is you got to make it so that the square root is all by itself first, which it is, and then you get rid of it by squaring both sides. So I end up with 25 equals 4x minus 3. And then now I just go ahead and solve for x. 25 plus 3 is 28. Divide by 4. And 28 divided by 4 is 7. Now what I meant by checking to see if it works is put 7 back into the original problem. It was 5 equals, be 4 times 7 minus 3. 4 times 7 is 28, and 28 minus 3 is 25, and the square root of 25 is 5. It works out. If this over here, after I put it in, would have given me a negative answer underneath that square root, throw it away. It doesn't work. If it's the only answer we got, then you have no solution. And unfortunately, you did all that work for nothing. So keep that in mind when going through it. The next type that you're going to have is something that, if it has higher degrees, but it looks like a quadratic. And what I mean by that is that a quadratic has, x squared minus or plus or minus something x, and then plus or minus a constant equals 0. This is in that format, but it's not an official quadratic because it's not squared. It's something higher power. But if you notice, this one here is always half as big as this one here. If it's set up that way, you can still use factoring. So what times what gives me x to the fourth would be x squared and x squared. What times what gives me positive 8 but adds up to be negative 8 would end up being something that does not work out. Now that I look at it, shame on me for not doing that. But in this particular case then, if it is something like that that would have factored, then we could go ahead and factor it, but that's not going to work because no matter what I multiply it, if I do 2 and 4 would not make 8, it would make 6. If I added them, and same thing with 1 and 8 would make 9 or 7. So for this particular case, what we're going to have to use, a technique called substitution. And what happens with that is I'm going to take this whole group here and I'm going to set z equals x squared. Okay? And the reason why I did that is because now if I have z is equal to x squared, then x to the fourth would be equal to z squared. And now what I have is I have a quadratic equation, which now if I can't factor it, I can put it in the quadratic formula and I can get an answer. So when I put that in the quadratic formula, negative 8 squared minus 4 times a times c all over 2 times a, I end up with 8 plus or minus the square root of 64 minus 32 all over 2. 64 minus 32 is 32. And the square root of 32, when you break it down, becomes 4 root 2. And if I divide each piece by 2, I end up with 4 plus or minus root 2. Now that's not the official answer because that was the answer for z, not x. So now I have to take x squared and set it equal to 4 plus or minus the square root of 2. And in order to get rid of something squared, you square root it. Now keep in mind, you cannot square root a negative number. However, if I do 4 plus root 2 or 4 minus root 2, I'm dealing with positives. So as far as my answer goes, I am okay with leaving it like this. All right. In some cases, it might say use a calculator to find the answer. In some cases, it might say, find the exact solution, which that would be exact. Most of the time, those types of questions like that can factor. However, if they don't, ones that don't factor are going to be, or ones that you'll really use substitution for. I mean, is one that's set up like this, where you have x plus 5 squared minus 3 times x plus 5 minus 10 equals 0. Now on something like this, I wanted you to see that these two pieces were exactly the same. If they're exactly the same, then what I can do is I can put z equal to whatever was inside that parentheses. Now the reason why I'm doing that is because I don't want to have to FOIL this out, although if I did, it would not be wrong. I would have to FOIL this piece out here, multiply that piece there, combine like terms, then I could have a quadratic and I could do it that way. A lot of extra work though. So for this one, I'm just going to do the putting it into z or using substitution and try to find my answer. So then what times what gives me negative 10 but adds up to be negative 3 is negative 5 and plus 2. So I end up with z equals 5 and z equals negative 2. Now for that, because it was z, now I put x plus 5 equals 5 and x plus 5 equals negative 2, and now I solve for x. Subtract 5, x equals 0. Subtract 5, x equals negative 7. So those are my two answers. Alright, so when it has excuse me. When it has something like that, then I would use the substitution method, where I'm going to take whatever's inside the parentheses, take it out and put it into something that looks like a quadratic. So, as far as section 5 goes, or not section 5, section 6, that is as far as what we're going to go through. So,